Hello Year 12, welcome to another maths lesson. As you can see, we are starting a new topic, which is titled Coordinate Geometry. Before I start the actual lesson, I want to discuss coordinate geometry and its purpose in a real-life context. So, as you can see on your screen, we have a map of most of Western Europe. Let's say you are a pilot who wishes to fly from London to Amsterdam. Well, you need to think about the distance between those two cities, the time in which it would take for you to fly that aircraft from London to Amsterdam, the speed in which it will go, how much fuel you will need, how much the whole journey will cost, and of course the cost then will allow you to think of what you're going to charge the passengers, of course. It's very difficult to calculate all of these things just by looking at a map, right? If we were to change the location, then yes, you could say, all right, the journey from London to Vienna is roughly 3 times as much or 4 times as much the journey of Amsterdam, but it's just not simply accurate enough. And if we, again, change the location, it doesn't matter. We need to work out a lot of information, and we cannot do that with this map. But if you add these grid lines, then it does make it a bit more easier. Now, it's still not perfect, but the grid lines would allow you to draw right angle triangles, and by drawing right angle triangles, you can then use your knowledge of Pythagoras' theorem to at least work out the distance of London to these three cities. Of course, you will also need to use the scales on the map to do that. Now, whilst these grid lines allow us to assign coordinates to certain points, they're still not accurate enough. If you look at London, for example, well, how are you able to identify the coordinates of a certain area within London? The grid lines are still not small enough to allow you to do that. However, we don't actually need to see the grid lines on a map. Every single location has a particular coordinate attached to it. For example, these two coordinates, whilst they are in a different form, will take you to the same place. Try Googling either of these, or maybe even both of them, and see what comes up. I am sure that Google took you to a particular part of London, which is where I was when I saved my location. And when I say saved my location, I mean I saved the coordinates, my GPS coordinates. And so that just highlights the importance of coordinates. If it weren't for coordinates, you wouldn't be able to send your location to your friend, and you wouldn't be able to get to places using Google Maps, for example. So I just want to show you how you can see the coordinates of your current location. Go on your compass app. This is a typo. So on my iPhone, I have a compass app, and underneath the picture of a compass, you will see the coordinates, and they will either be in this form or in this form. If you were to click on those coordinates, then it would take you to your location in your default Maps app. So mine is Google Maps, yours might be Waze or Apple Maps. But yeah, you would see your current location on there. In terms of what you need to learn within this topic, I have included all the learning objectives here on the screen. Now, you will see that a lot of this has already been covered in GCSE. However, similar to some of the other topics such as trigonometry, surds and indices, the questions at A-level are a lot more difficult. So it is really important to deepen your understanding of the concepts within these topics. Now, I've spoken to some of you individually about integral maths and the resources on there. I think the resources are great, and as you can see here on your screen, underneath learn, there are loads of videos related to what we're going to learn today. So if you get through today's lesson and you realize that, okay, there are aspects of today's lesson which you find difficult, then click on the relevant video and then you can watch it. You could do the same for some other topics as well. I actually just noticed that Integral Maths have been uploading these videos for a number of topics. So please make sure you're using these videos to help you if, for example, you are stuck on anything really. They also have these little checkboxes here on the right, so you can tick off the videos you've watched, and that would help you organize your revision. So for today's lesson, I will actually use some of the resources from Integral Maths. So we're going to start off by clicking on this link here. And that would take us to this screen here. I'm going to click on Explore Points. So I'm going to start off with this one, the midpoint of 2 points. So here we have 2 points. If I click on Show Midpoint, it will show us how to work out the midpoint of those 2 points. Now by going on to the distance between 2 points, again I can see how we work out the distance, and this is something which is linked to the hook at the start of the lesson where I showed you a map and I said that using Pythagoras' theorem you'd be able to work out the distance between London and Amsterdam, for example. The gradient of a line joining 2 points. So again, you guys know from GCSE that the gradient is equal to change in y over change in x. So the change in y is -6 and change in x is 9. So feel free to have a play around with this GeoGebra link. And after you've done that, then have a go at the skill pack activity. So the first skill pack activity, I'll just show you how it works. You click on next and it shows you how to work out the answer for this question. So here it is. This is how you work out the midpoint. Then when you click on practice, then you can answer this question yourself. And after you've answered it, you can check to see whether your answer is right or wrong. And of course, you could do further practice by clicking on this new here, and it will change the question, as you can see. So I'd like you to please do this skill pack activity for midpoints, distances, and gradients. And when you have completed the activity, then continue with this lesson. Okay, now we're going to focus on equations of straight lines. So I'm going to go back to this Integral Maths link. And now I'm going to click on Explore Equations of Straight Lines. So y equals mx plus c. Let me just tick this. So now you can see y equals 2x take away 1. But if I change the gradient, let's see what's going to happen. So the gradient's getting steeper, right? Because the higher the gradient, the steeper the line. Now let's decrease the gradient. M equals 0. Watch what happens to the line. Of course, it's just a horizontal line. Now let's see what happens when you have a negative gradient. Well, the line is going in the opposite direction. And now look at the line is getting steeper and steeper the more we decrease the gradient. Now, of course, let's go on a steady gradient. The y-intercept will, of course, move the line up and down. The gradient isn't changing, of course, but the line is just moving up and down by 1 point. So again, feel free to play around with these GeoGebra links if you think that it will help your understanding of equations of straight lines. So here we have a line in the form of ax plus by plus c equals 0. Of course, when you have a line like this, sorry, an equation like this, you'd have to rearrange it so that it's in the form y equals mx plus c to help you understand what the gradient is, what the y-intercept is. But again, you can play around with this and see what happens. It's clear that a, with it being the coefficient of x, it's directly affecting the gradient. B, it's interesting to see what b, so b is also affecting the gradient because of course if the coefficient of the y is 1, then the gradient will just, in this case, be -3. But if you move it around, make it 2, for example, the gradient would be -3 over 2. Then we have -3 over 3, -3 over 4. So yeah, feel free to play around with these to see what happens. Equation of a line from gradient and a point. So, as you guys know, m equals change in y over change in x. So if you multiply both sides by change in x, you get this equation, y take away y1 equals m multiplied by x take away x1. So now let's see what happens if we change the gradient. So it starts off at 0. Now let's increase it. Of course, the line is getting steeper and steeper. And look at the blue equations as well. Not only is the gradient changing, but the y-intercept is changing as well. So now I would like you to try the skill pack straight lines activity. Oops. So here, find the gradient of a line and the coordinates of the points at which the line cuts the coordinates axis. So you'd have to rearrange to get into the form y equals mx plus c. Substitute x equals 0. Substitute y equals 0. And then you have your 2 points, your 2 coordinates for when the line crosses the y and x axes. Now, of course, you could click new and do another example, but I'd like you to try the practice questions and then check your answer. Finding an equation of a line given its gradient and a point on the line. So we're using this equation. Remember, change in y over change in x equals the gradient, but here we've multiplied both sides by change in x. So we substitute the values of the coordinates 2 and 5. Then we have our equation in the form of y equals mx plus c. Now we know what our gradient is and what our y-intercept is as well. Press practice and try this question. And then we have a third example, which is finding the equation of a line through 2 points. And here we have to give our equation in the form ay plus bx plus c equals 0. So find the gradient of a line. Well, we have 2 pairs of coordinates. So change in y over change in x. And our gradient is -3. Now we're going to use this equation. Substitute coordinates. Now we could substitute the coordinates -3 and 2 as well. By rearranging y plus 4 equals -3x take away 3, we get this as our equation. Try the practice questions now. And when you're finished the practice questions for all 3 subsections, then please continue with today's lesson. So your first independent activity is to answer the question you see on your screen. So The question is, find the perpendicular bisector of the line joining the points -2, 11 and 4, -7. Follow the solution and explain what is happening at each stage. So they've already given us the answers, the solutions. We need to explain what is happening at each stage. Please pause this video, have a go at answering the question, and press play when you are ready to see me going through the answers. Okay, so step 1, I can see -18/6. Well, that is clearly working out the gradient. So work out gradient of the line. Now, using the -3, we have worked out 1/3. So we've written the negative reciprocal of -3. Why? Because it's the gradient of a perpendicular line. So gradient of perpendicular line. So below that we have the equation of a perpendicular line, and of course we need to work out what C is. One, two. Now, what is that? What does that mean? Well, let's sketch our graph. So -2, 11 is here, roughly. 4, -7 is here. So let's just say this is our line. Actually, that's not a very good drawing. Okay, so that's a rough sketch of our line. And we need to work out the equation of the perpendicular bisector, right? So let's draw the perpendicular bisector. So 1, 2 is the midpoint of the 2 points I've underlined. So midpoint of this point and this point. The reason why we need to work out the midpoint is because we need to find the perpendicular bisector. And so we need this point over here. We need the midpoint. So the midpoint is 1, 2. Then we substitute 1, 2 into the equation of the perpendicular line. We work out what C is, write the equation of a perpendicular line where we've actually written what C is, and the last step is just multiplying both sides by 3 so that we don't have any fractions. This last step isn't really necessary, however it cleans it up a bit, it looks a bit nicer now that we don't have any fractions here. So now we're going to come on to the third explore link, which is parallel and perpendicular lines. So again, you would have learnt this at GCSE. However, it's always useful just to come back to it. Here we have two parallel lines. As you can see, the one thing which they have in common is they both have the same gradient. All parallel lines have the same gradient. Now look, I'm decreasing the gradient, and so the line is becoming less steep. But interestingly, the lower the gradient, the closer the two lines are to one another. If I increase the gradient, then the lines are also further apart. So that's a useful thing to bear in mind. Perpendicular lines. Let's move this And so the two gradients multiply together to give you -1. So here we have the blue line has a gradient of 1/2, the red line has a gradient of -2. And so yeah, one of the gradients is the negative reciprocal of the other gradient. So have a go at the skill pack practice questions. Here it says finding the equation of a line parallel to a given line. Well, we know the gradients will have to be the same. Write down the gradient of the original. The gradients of parallel lines are equal. So using this equation, we substitute those points, and rearranging, we get an equation in the form of y equals mx plus c. So have a go at these practice questions. Then with the perpendicular lines, the gradient is -2, so the gradient of the perpendicular line will have to be 1/2. Yeah, there it is. Now the rest is the same as what we did for the previous example. Substitute into that equation, rearrange, and here, okay, they've written it in this form. It's fine to write it in the ax plus by plus c equals 0 form as well. But of course, in an exam, they'll ask you for which form they'd want the equation in. So have a go at these practice questions. Then when you are done, come back to our lesson. So your second activity is to have a go at answering these problem-solving questions. All you need to do is, when you see the question, pause the video, answer the question, press play again to then see the solutions, and then you have to mark your work. There are 5 questions in total, and you will see that I'll provide some hints as well to help you if you are stuck. So here is question 1. What is the midpoint of the midpoint of A and B and the midpoint of A and C? So pause this video. If you'd like a hint, then don't pause the video, keep playing on, and I'll give you one in a few seconds. But yeah, if you've paused the video, then press play when you're ready to see the answer. Okay, in terms of a hint, what I'm going to do just to help you answer this question, I'm going to draw a line from B to C. Now you need to work out the midpoint of A and B and then work out the midpoint of A and C. Pause the video, try to answer the question using this hint, press play when you're ready to see the answer. So as you can see, the midpoints are 2, -2 and 5, 1. Now we need to work out the midpoint of these 2 red points, and so you could do 2 plus 5 over 2, -2 plus 1 over 2, so we get 7 over 2, and that would be -1 over 2. And so yeah, as a decimal, this would be your answer. Question 2. Find 2 consecutive integers so that the gradient of a line shown lies between them. Okay, so pause this video if you don't want the hint. Just don't do anything, keep playing it if you'd like a hint. So the hint I will provide is I'm going to draw 2 lines. I'm not going to say why right now. Oops, sorry, that line isn't too straight, but yeah, I'm not going to say right now, But I like you to use that. Maybe think about gradients, think about changing y over changing x. And yeah, hopefully it helps you. Press pause, try to answer this question. Press play when you're ready to see the answer. Okay, so I am going to work out the gradient of this line, this red line. So changing y is 2, changing x is 2, so the gradient is 1. So I'll write here m1 equals 1. Now as for the steeper red line, 4, the height is 4, and the base is 2, so 4 over 2. So I'll write m2 equals 4 over 2, which is 2. Now the reason why I drew these two red lines is because this line here has to have a gradient which is smaller than 2, because obviously this line here is steeper than this line, but the gradient has to be higher than 1, because as you can see here, this line is not as steep as this line is. So find two consecutive integers so that the gradient of a line shown lies between them. So those two consecutive integers are 1 and 2. Question 3. For which value of A is the area shown equal to 16? Now by area shown, they mean the area of a shaded region, so that triangle you see. So pause this video to answer the question. My hint for this question is to... Okay, so we know that this is A, this is A. So I'm going to draw, I hope I haven't made it too easy, but I'm going to draw a square. But there are multiple ways of working out this question. But yeah, hopefully this is a nice enough hint to get you started. Pause the video, press play when you're ready to see the answer. So the area of the square is obviously a squared, right? A multiplied by A gives you a squared. The shaded area is exactly a quarter of this. So A squared equals, A squared over 4 is the area of a shaded region. So A squared equals 4 is equal to 16. Oops. Now that means A squared is equal to 64. And so A, bearing in mind A has to be positive, is equal to 8. Now another way of working out this question is just working out the area of this triangle. Draw a dotted line here. So this height will be A over 2. So the area of a triangle is half multiplied by A multiplied by A over 2, which is the height of a triangle, even though it's slanted. And so that would give us an area of A squared over 4. And so, yeah, then we can say a squared over 4 equals 16, and we can just continue solving for solving for a as we did using the other method. The shaded shape shown is a rectangle. What is the equation of the orange line? So we have it looks red to me, but anyways, in terms of the clue for this question, of course, pause the video if you don't want to hear the clue. But in terms of the clue, I would say, we have 2 points. So think of what you can work out using 2 points. And I'll draw a right angle here. And yeah, so hopefully that helps you answer this question. Pause the video, press play when you're ready to see the answer. So the answer is here. The gradient of AB is 2. So the gradient of the orange line, which is perpendicular to AB, and that's why I drew the right angle, is going to be negative 1 over 2. Now I don't have enough information to work out the equation of the orange line just yet. I only know the gradient, so I'm going to use this purple line. So I know the gradient is 2. So I'm going to write y, take away 0. I'm going to use this coordinate equals 2 x take away negative 2. That's y equals 2x plus 2. Sorry, x plus 2, which equals 2x plus 4. So now I know that this point here is 0, 4. And I know the y-intercept of the orange line. So now the orange line has an equation of y equals negative half x plus 4, because it's clear to see that the y-intercept is 4. The last problem solving question. Point A is in the red region. Point B is in the blue region. The gradient of AB in this diagram is 0.8. Could this be true or must it be false? Why? So my clue for this question is, so I'm going to ask a question. Is this green line steeper than this line from this point to this point? Which line is steeper? Just think about that. And yeah, you might have to do some calculations as well. So yeah, pause this video, have a go at answering this question, and press play when you're ready to see the answer. So we can clearly see that this line, which goes from -5 to 5, 5, is steeper than the green line. So this line has to have a higher gradient. So let's say M1 and M2. Well, M1 has to be higher than M2. That's one thing we know from this diagram. And so let's work out M1. We have 2 coordinates. We can work out change in y over change in x. So M1 is 0.7. And so M2 cannot be 0.8. Why not? Because M2 has to be smaller than 0.7. So the statement is clearly false. Activity 3, I would like you to go back to this link on Integral Maths and answer at least 3 questions from exercise level 2. The answers are of course on Integral Maths, so mark your work after you've answered those questions. Now the reason why I have asked you to answer at least 3 questions is because I want you to work at a difficulty level which is comfortable for yourself. And so if you're finding this work easy, then answer the 3 final questions from that worksheet. If you're finding this work quite difficult, then feel free to watch those additional videos to help you and answer maybe the first 3 questions, because that will cover the basics. But yeah, whatever you do, make sure you mark your work to see whether your answers are correct or not. After you have done that, then please complete this test on Integral Maths, multiple choice test, which would tell me how hard or easy you have found this lesson, and it would help me a lot. For example, if a lot of students are struggling with question 5, then I know that might be something I could revisit at the start of next lesson, for example. So yeah, please make sure you complete all 3 activities, but especially this final activity, and make sure you attach a picture of your work to this team's assignment. So if you have any questions, please make sure you email me or contact me through Teams. And yeah, take care for now, and I'll speak to you guys soon. Goodbye.